Welcome in, everybody. This week is going to be all about looping algorithms. We're going to be applying the for loops in particular. Last week we talked about the basic syntax for loops and while loops. By now you should be able to write for loops that can access things. We did this in the previous lab over here. I think it was lab 15. This is the prerequisite for today. Make sure you can do the lab 15. It's really just looping print statements. Okay, let's jump into today. It might be a little dense actually. We might take the full 2 hours today talking about looping algorithms. We'll see. But today we're gonna cover the lesson, a part of the lab, and then on Thursday we're going to give some hints into this next project. This next project is called Major League Baseball Players and is going to involve using a large data set and looping over it to calculate certain things. It's kind of like the basics of data science. Nowadays, in the AI world, a lot of AI algorithms learn from large amounts of data. So this assignment will kind of help us maybe visualize that. Anyways, we'll talk about this assignment on Thursday in 2 more days. So let's talk about looping algorithms. I think folks might find this interesting for the software engineering people. People who are interested in applying for software engineering internships, or maybe maybe getting better at problem solving in general. You'll find this topic pretty interesting. For the software engineers, there's something called a technical interview, where when you apply for a job and you get the interview, one of the rounds will consist of a person asking you a problem and seeing if you can solve it. An example of this is in the Google interview. Whoops, let me pull up a YouTube real quick. There is an example of a Google coding interview. It's kind of staged, but I've experienced a few of them, and it's pretty accurate. So I'm gonna Google up, YouTube it. I'm gonna YouTube the Google coding interview. Let's see. There is a demonstration somewhere. Let's see. Over here. This demonstration is made by Google, the author. It's kind of staged, but once again, it's something that's very popular if you're applying for, a engineering job, especially if you're applying to some company at Silicon Valley. This is highly likely to be what an interview looks like. Basically, there's the applicant on the left, and then there's the interviewer on the right. I have the video muted. You can watch this on your own time. I'm just gonna skip through it. Basically, this interviewer is asking the applicant a question, saying something like, hey, are you able to solve this problem? And the problem involves a data structure of elements. In this case, they're using a kind of like a list of integers. And the problem is, it's really a searching problem. Basically, the applicant is supposed to develop some sort of algorithm that goes through a data structure and searches for something. So basically, you don't have to know what the problem is, as long as you kind of see what I mean. But basically, the applicant is supposed to design a looping algorithm. That's really what he's supposed to do. So they're brainstorming right now. It's a good idea during these technical interviews to not jump to the solution. It's usually a good idea to explain your thought process, ask some questions along the way. This way it'll kind of show your problem solving abilities, the way you're thinking out loud. So the person on the left right here is thinking out loud asking some questions, clarifying questions, like, hey, am I expected to do this? Am I expected to design an algorithm that handles this? So something like that, right? Just some clarifying questions, kind of building up to the solution. And yeah, thinking out loud right now. At some point, the applicant is going to write in code. The interviewer is going to say something like, what language would you like to program this in? And then the applicant will be like, oh, I would like to program in Python. I would like to program in C++. Well, whatever language they're comfortable in. In this case, the applicant is comfortable with C++, so they're going to code it in C++. It's a different language. He's writing a function that takes in a data structure and returns some sort of value. Okay, and kind of thinking out loud, if you kind of check this out right here, there's a while loop. So he's designing an algorithm, a looping algorithm, with his while loop. Okay. Oh, and it looks like he ended up erasing it. So this is basically a naive solution, meaning that it's inefficient and it could be done better. So the applicant on the left is saying, you know what, this could be done better. And then ends up erasing it all. Ends up erasing it and then says, here's a better approach that will save more time. There he goes, thinking about the problem again. And then explaining a more efficient solution. In this case, the solution it's a different looping algorithm, but it's a little more efficient. So in all, this is what a technical interview looks like. It's very likely that the question will be, hey, here is some data. Can you write a function that deals with this data and does something? That's really what it is. There's a lot of popular algorithms out there. I mean, popular interview questions out there. There's a very popular one called FizzBuzz. FizzBuzz is an analogy for a kind of like a small. It's basically a question that asks if you can write a loop with conditions in it. If you want to take a look at it, let's see. LeetCode. Let me see. There might be a paywall here. Let me see. Oh yeah, you can take a look at this question on your own time if you want. But it's pretty much asking if you can write a loop that prints certain things. Let me look at a different one. Probably this Geeks for Geeks. Yeah. This is a very popular one as well. It's a little easier than this Google one, but a FizzBuzz is typically one of the first rounds. Typically in software engineering positions, or not software engineering, just engineering in general. There's a few rounds of interviews. The rounds get harder and harder. So this is usually like the second round, and this one is usually probably like the second to last round. Okay, so yeah, that's pretty much what we're gonna be talking about today. Looping algorithms that go through data and does something with it. Okay. Yeah, I hope that makes sense. Let's go to the notebook, the lesson. The lesson is over here, number 15. Let's see. No, not 15. It's number 17, my bad. Lesson number 17, algorithms. Okay. We're going to go through a few types of general algorithms that deal with lists. In particular, we're going to see something called a reduction algorithm, which does something with a sequence of values and collapses it into a single thing. We'll see another one called filtering, which is taking a sequence of items and then giving us another sequence of possibly less items. And then we'll see a mapping algorithm. What's up with my... We'll see a mapping algorithm that pretty much converts a sequence to another sequence of the same size. So that's really it for today. Just gonna go through 3 general algorithms. Okay. Let's start. This notebook will kind of use a very general scenario. I'm going to be using a scenario that pretends to deal with student grades, and it might be a little more concrete. Anyways, let's say that we were to add up the elements in a list for some reason. Like, let's say we have a list of some random numbers. Here's some random numbers hard-coded. If for some reason you wanted to calculate the sum of everything in here, there's a couple ways of doing that. There is a automatic way. I'll show the easy way first. The automatic way is kind of by using a provided function already. There actually is a provided function that calculates the sum of this already. For example, you can say, you can use this sum function. This is provided in the native Python. It can take a list. So if I put numbers in here, this function will sum up all the numbers and then evaluate to a single number. This does return something, so I'm gonna store it into a variable called total, and just print it. Total is total. Let me put this in an F string. So the total here is 188. Makes sense, that's the sum of all of these. This is the easy way because it uses a provided function to do the work for us. That's not what we're going to do in this notebook though. This lesson is meant to study the workings of how the algorithm works. So we should probably unpack what's going on inside of this function. Okay, let's unpack it. Let's pretend like there is a function called let's see. Let me make another function. Let's say I'll call it like my sum. No, that's a bad name. I'll call it, yeah, I'll just call it my sum. But basically, I just want to use a different function that doesn't clash with the original one. So I'll just name it my sum. And imagine if we were to rewrite this function. So I'm going to go ahead and make another cell called my sum. Another function, I mean. And the goal here is to unpack what's going on in the original sum function. It's a good idea to understand how the black boxes work. This way, when you get to an actual problem-solving exercise, you'll be able to kind of see why things are efficient and how things can be improved. So in this case, this my sum function should take an argument. This argument is, you can call it whatever you want. I'll name it values. You can literally name this whatever you want. I'll just name it values. And the point of this is to return some number. I'm gonna return 0 for now actually, just so I can build from the bottom up. This is a temporary placeholder, meaning that if we were to calculate the sum, the total is 0. If anything, we need to modify this function to actually go through this list. So we can think of it as calculating a total, like I'll store in a function, a variable called result, and return it. So imagine we initialize a variable, and then somewhere in between we would accumulate the result and then return it in the end. So when we're talking about accumulating, I'm talking about going through all of the numbers in this list. So right away we should be able to write a for loop that goes through all the numbers in the list. So for number in values, we need to accumulate this result, meaning that result must get bigger upon every iteration. So in this case, result is going to accumulate the number. So I'm gonna press play here, and we'll see that the total is now 188. So that's the same exact thing as previously when we did the original function, the provided sum function here. But now we kind of wrote our own mySum, which does a same exact thing. So yeah, hopefully people kind of see what's going on here. I do want to mention that this notebook mentions something called the debugger. Let's not worry too much about the debugger. This is a tool that's provided in this notebook, the Jupyter server. It's right here on the top right. There's this debugger. I'm not going to go over this too much. It's basically got a lot of functionality where you can pause the program in between and trace code line by line. I'm not going to talk about the debugger too much. If anything, we should probably manually debug, meaning not rely on this tool to figure out what's going on. One classic way of debugging things is to trace code. And one way of tracing code is to print, meaning to maybe visualize the values of certain variables. So in this case, I'm going to kind of debug what's going on in the for loop. If I do a print statement in here that just says result is currently result, we're going to see multiple print statements here. So let me go ahead and load this in. Okay, so I just loaded the function, and now I pressed play. I invoke the function. We see that there's some tracing going on here. This is what I kind of mean by debugging. It's kind of visualizing the result as the program plays. So yeah, we get the result getting bigger and bigger. And if you want to take a look at what's happening here, there's a table that kind of describes each iteration. Basically, the result is being accumulated. It's getting bigger and bigger within every iteration. Okay, so hopefully people kind of see what's going on. 1 is the first number, and then we accumulated 23, so it became 24. We accumulate 46, so it gets bigger. We accumulate 92, it becomes another bigger number. Yeah, hopefully people see what's going on in here. Okay, we just unpacked what's going on in the sum function. Yeah, this is pretty much what's going on. So this is an example of a reduction algorithm where you take a sequence of things and collapse them into a single value. We're going to see some more of this later. Let's do another reduction algorithm. Maybe let's do a more concrete scenario. This scenario up here is really just dealing with numbers, very general. Maybe let's deal with like grades instead. Pretend that we have a list of grades where each element represents the percentage. Like let's say someone's grade is 75, another person got a 100 in the class, and maybe someone has like a 47 in the class, and maybe another person has like 80 and maybe a 95. Yeah. Imagine if we were to calculate the average of this. Like if we were to have a function called average that takes in grades, and assume that this function returns a number. So you could store that number into a variable. I'll call it mean, which is synonymous with average. I'm using a different name here. So if we were to kind of print the mean as an f string, well, first of all, this is not gonna run because we don't have this function. We could go ahead and define this function. By the way, there is a Python function that can already do this for you, but we're pretty much going to unpack what's going on inside of that function. So let me make another cell up here and define a function called average. This is going to be a reduction algorithm that takes in a list of values and collapses them into a single number. I'm gonna do a dummy return statement for now, like say result is equal to 0, and then here I'm just gonna return result. I'm just kind of setting up the function. So if I were to press play again here, we see that the mean is 0. Perfect. We didn't get any syntax errors, so we can continue with this algorithm. The average, hopefully people know how to calculate the average. It's the sum of all of the numbers divided by the length. That's how you calculate the average. So this is the same as the previous question pretty much. It's you're gonna want to calculate the sum and then divide it by how many items there are in these values. So yeah, let's calculate the sum. Equals result plus number. This for loop is accumulating all of the numbers in this list, and then finally we just have to make one modification. It's you want to divide the result by the length, because that gives you the average. So I'll press play and then press play here, and we see that the mean is 79.4. This kind of makes sense. Let's kind of sanity check. Like maybe if we were to try with two different numbers, like 90 and then 100, what is the average score? The average score should be 95. So let's see. 95. Perfect. Okay, let me just add in some more numbers. 0, 70, 47, just some random numbers. So now the average is different. Now the average is 61.4. Okay, people getting a sense in what a reduction algorithm is. It's converting a sequence and collapsing it to a single value. Okay, let me see. I do want to talk about debugging, because when designing looping algorithms, it's possible to run into errors. Let me think of a possible error here. What's a possible error? I can't think of any right now, but if you were to get an incorrect result somehow, and maybe you want to narrow down what's happening, and once again, you could do some print statements. Like you could print sum is currently result. This is just visualizing what's going on with the result. And then after the loop, you could maybe visualize what the length is for some reason. So you could say length is a length of values. And then let me make this an f string. So this function has some debugging statements here, meaning that if we were to invoke the function, we're going to see some print statements. The function is telling us the sum. The sum is 307 in the end, and then the length is 5. So the mean is 307 divided by 5. This is what I kind of mean by debugging, just visualizing things along the way. Once again, there is a debugger in Python, in this Jupyter server, but I'm not going to go over it too much. It's quite a bit of functionality here that might make things more confusing than it is. But debugging manually is probably a good first start. Debugging manually with print statements. All right, people cool with this so far? Okay, great. Let's move on to a different type of algorithm. Generically, this is called a filtering algorithm that pretty much takes a sequence of items and converts it into another sequence that can possibly be smaller. For example, let's use the grades example. I'm gonna copy this line. Let's use this as a scenario. Maybe for some reason we wanted to filter out the failed grades. But I'm just making a hypothetical scenario. Let's say we have a list here and we want to generate another list called like past grades. Imagine if we had another list called past grades, and then I'll set it equal to the some algorithm. Like let me pretend like there's a function called I'm trying to think of a function name. I'll call it like filter fails, filter passes. Yeah, this is a good name. Basically, this is a function. It doesn't exist yet, but you can kind of see what it's supposed to do. It's supposed to take a list, and the passed grades, this should represent a list of all of the grades that passed, meaning that it should have 90, 100, and 40, and a 70 right here. So if I were to print out the passed grades, it should print out only 3 numbers. That's what I'm saying. This should be a list. So that's the filtering algorithm here that we're going to implement. Okay. This is not going to compile yet. I mean, not compile. It's not going to run yet because we need to make a function called filter passes, meaning to filter all of the people who passed. So I'll define a function called filter passes, and it's going to take a argument, a parameter. I'll call it values. You can call it whatever. Okay, so this filtering algorithm, we're expecting it to return a list, meaning that we could create an empty list at first, and then somewhere in between we'll fill up that list and then return it in the end. Okay. Here, so I'm gonna press play real quick so people see what I mean. Basically, this is a temporary placeholder. If I were to invoke the function, it's going to return an empty list, but it should return a list that has 3 numbers, 90, 100, and 70. So we need to design this algorithm to iterate through the list and check if those certain numbers are within a certain range. So let me go ahead and write a loop for number in values. We're going through all of the elements, and now we need to find a condition to add to this list. For this case, in order to pass, the grade must be greater than or equal to 70. So you could say if the number is greater than or equal to 70, then this is a passing grade, meaning we can add it to this list. So you might remember that there's an append function for the list that adds an element to the end. Okay, people see what's happening here. This is saying for all of the numbers, if the number is a passing grade, then add it to the list. So the list will get bigger and bigger. Okay, let me play this here. So press play here. Okay, people see what's happening here. The output consists of 3 numbers, which is, yeah, that's perfect. We filtered out the ones that are less than 70. If you wanted to visualize this algorithm a bit, like instead of using the debugger here, we could do it manually by printing. I'm gonna print it manually over here inside of the for loop. I'm gonna do a print statement. This way you can kind of visualize what's happening. I'll say output, or I'll say filtered list is currently, and then let me put it here as an f string. So we're gonna get a bunch of lines here. Press play, and we see what's happening here. Filtered list is currently empty. That's in the first iteration. It's empty, and then the algorithm sees the number 90. 90 is greater than 70, so we add it to the list, and then the resulting, on the next iteration, we see that it prints 90 here. And then the algorithm sees 100. 100 is a passing grade, so we append it to the list, And then the algorithm sees 0. 0 is not a passing grade, so the list remains the same here. The algorithm then goes to 70. 70 is a passing grade, so the list gets updated, gets appended 70. And then finally 47. This doesn't get added because it's less than this. So yeah, here's our remaining list. Okay, people cool with this so far? Here's a table that kind of represents what's going on. This notebook uses a more general scenario, but it's pretty much the same thing as what we're doing here. We're just filtering numbers based off some criteria. Any questions about this so far? Okay. Okay. Let's continue then. Finally, there is another generic looping algorithm that it pretty much is a conversion. Sometimes it's necessary to convert a whole sequence to another sequence. Like maybe for some reason you had a sequence of like metric system. I'm talking about like measurements in the metric system, and maybe for some reason you wanted to convert it to another system, the United States imperial system. You could design an algorithm that does this. So yeah, the mapping algorithm is kind of like the filtering one, but we're going to end up with a new list. To keep the scenario the same, we're going to deal with grades, and maybe let's say that we wanted to curve the grades. You can think of curving grades as mapping, meaning that if the grades are something, then we curve the grades and they become another number. So let's do that. Let's say we wanted to curve these grades, and imagine if there is a function called curve grades takes this, and let me store this into a variable, a list variable called updated grades. Basically, I'm saying that we have an original list and I want to curve them. To keep things simple, maybe we'll use a easy function like double their grades. Maybe for some reason I wanted to double everyone's number. So let's do that. Let me print the updated grades here. Basically, we're expecting this print statement to print 180, 200, 0, 140, and then 47 times 2. So let's go ahead and design this function. Values. You know what, I'm going to use a different name for this function because typically curving grades doesn't involve doubling. Curving grades uses a more statistical constraint. I'm going to make this more general, maybe double numbers. I'll just call it double numbers. The goal of this function is to return a list where all the values are doubled. Okay. If anything, we just need to take a step by step. This function is expected to return a list. So I'm going to go ahead and create a list. I'll call it output. I'll set it equal to an empty list. And then, we return it. This way the caller can get the value. Let me test it real quick. Okay, cool. I'm just testing it, make sure I don't have any typos. Currently, the updated grades is an empty, so we should populate this empty list. Okay. Well, we are going to go through the values here, so you could do that with a for loop. And basically, we're not really going to need an if statement here like previously. Previously, we did a filtering algorithm that has an if statement. This if statement was a constraint, but we don't really need a constraint in here because we're dealing with every element. In particular, we're going to double every element. So number times 2. This is calculating the doubled number. And yeah, we just have to kind of append this number to the list. A couple ways. You can do it in 2 lines, you can do it in 1. I'll do it in 2 lines. First, I'll store this result into here. I'll store into a variable called doubled, meaning that I can just append it to the list. So yeah, every number gets doubled and we're gonna append it here. So let me load it in and then invoke the function here. And we see that the updated grades are all doubled. People see what's happening here. If you're not sure what's happening here, you can do some print statements again. Like, I'm gonna put the print statement in at the end here actually. I'll do a print statement that shows the list. Current list is output. That's the list. So this is a debugging statement, and we're gonna get a bunch of print statements here, and we see that the list gets bigger and bigger. So there's a table up here that kind of does the same thing. It pretty much helps you visualize each iteration. So yeah, feel free to take a look at all of this. This is really just the print statements. Okay. Any questions about this so far? Double numbers, mapping algorithms. Okay, cool. Let's move on. Give me 1 minute. I'm gonna see if we should move to the lab. Let me see real quick. Okay, we got another filtering algorithm here. Okay. Okay, let's finish this. We're pretty much done with the notebook actually. We just have to cover one more filtering algorithm. But just to summarize what we did so far, we covered 3 generic looping algorithms. One was a reduction algorithm that collapses a sequence into a single value. Another one was a filtering algorithm that converts a list to a possibly smaller list. And then finally we did a mapping algorithm, which is it's converting a list to another list of the same size. If you're curious, most of these algorithms can be done in 1 line. Not by calling a certain Python function, but using something called lambda functions. I'm not going to cover it in this class, but if you wanted to write some really cool one-liners in Python, you could look up lambda functions, and these are pretty much what we're doing. These are shortcuts. It's shortcuts. So let's cover one more thing. This is in a filtering algorithm, kind of. It's a reduction algorithm. Sometimes it's necessary to go through a data structure and see if something exists. For example, let's stick with the grades example here. I'm gonna copy this list over and going to the bottom of the notebook. Let's say for some reason we wanted to search the list to see if there is 100 just for some reason. Let's see. Let's say there's a function called has 100 where it takes in a list and tells us whether or not 100 exists in here. Or here, let me generalize this function a little more. Let me call this has number. And to keep it more general, I'm going to add another argument here, like maybe 100. So basically I'm trying to say, hey function, does the number 100 exist in this list? This is supposed to return some sort of Boolean because we're expecting it to be true or false. So I'm going to store it in a Boolean variable. I'll call it exists. That this is a true or false. It's not a number. So if we were to print it, it should say true. This should print true. Okay, so this is an example of a searching algorithm, which is a reduction algorithm. It's going through a whole sequence and giving us a single Boolean value. So let's go ahead and design this function. Define a function called hasNumber. This is a general function that takes two arguments. One is a list of numbers, and then another one is the target. So the target is what we're looking into here. Oh, by the way, just a quick side note. We're really redesigning a operator called in. If you're curious what we're doing, Python already has this built in. But basically, there's this operator that says in. That this is a Boolean operator that searches things. The target goes on the left side, and then on the right side is some sequence. This expression will evaluate to true or false. In this case, it evaluates to true because 100 does exist in grades. But if 100 didn't exist, let me delete 100 real quick. So I'll delete 100, keep it 0. Now it prints false because it's no longer in there. So yeah, that's really what we're designing, this in operator. We're unpacking what's going on in this operation. It's really a searching algorithm. Okay, so let's go ahead and design this right here. Let me clear this cell output. Okay, so yeah, it does exist in Python, but we should probably understand what's happening. So this is expected to return some sort of Boolean. I'm gonna hard code like a false for now. I'm gonna hard code it to return false, just temporarily. Press play and press play here. Okay, it prints false because we hard coded return false. If anything, we need to actually search the numbers. So we need to iterate through all of these numbers and see if the value matches the target. So, you could think of it as going through all of the values in numbers. Whoops, this should not be plural. It should be singular value. So we're going to go through all the value, and then we need to kind of compare. If the target does match the value, this is the condition where we found the number. And you can do a early termination here. You can do an early termination, meaning that there's no need to check the next numbers. If we found a value earlier, there's no need to go to the next numbers. So you just have to return true, means to quit the function early. So this is called a premature termination or premature return, meaning that we didn't go through the whole list. You know what I mean? This algorithm is saying, hey, look at 90. Is this equal to the target? No, it's not. Go to the next number. Is this value equal to the target? Yes, it is. There's no need to check the next numbers. Just quit the function, return true to the caller. So it's going to quit early, return true to the caller, and then we'll get true here. People see what I mean here. So I do want to point out a possible logical error. It's possible for some people to design this function and put the return false in a separate statement. Some people might say, if the target doesn't match the value, then return false. This is a common logical error where it looks right, but it's not going to give us the right solution, the right value. If I were to press play here, invoke it, it says false. It should return true though, because 100 does exist in here. So if folks want to maybe pause the video and think about why this doesn't work, that would be great. It's not working because this is also a premature return, meaning that the algorithm won't have a chance to see the next numbers. This design is looking at 90. It's saying, hey, does 90 equal the target? No, it doesn't. So it's going to return false, meaning terminate the function. False will be returned to the caller down here, and the algorithm will have no chance to check the next numbers. So yeah, hopefully people see the logical error here. The return false should be outside of the loop, because if we finish the loop, it means it never existed. So we'll just return false as a default, meaning we never found it. Okay, hopefully that kind of makes sense. And just to keep testing it, let me erase 100 here. Go 0. It should print false. So yeah, perfect. Prints false. Let me put 100 over here in a different position. Yeah, true, because it does exist. Let me keep testing. Let me change this target here. Let's say I were to see if 47 exists. 47 does exist, so it's true. Let me change it to 46. 46 doesn't exist, so it returns false. Okay, people see what we did. All we really did was unpack what's going on in this operation right here. I'll pull up a terminal actually. I'll pull up a Python terminal so people see what I mean. Basically, we're redesigning the in operation, like is hello in this list right here. Let me hard code a list of world and then hello. In this case, hello does exist, so it returns true. If I were to remove hello and say hi, this now evaluates to false. So yeah, that's really what we did. We unpacked what's going on in the in. It might seem like a small thing, but there's a lot happening here. Okay. Any questions so far? Okay, cool. This is an example of a searching algorithm. There's a lot of different approaches to this searching algorithm. You can take a look through these if you want. It's pretty much doing the same thing, but in different styles. So yeah, feel free to take a look at this. And then here's the debugging. It's kind of tracing what's going on in the algorithm. There's more approaches. There's typically infinite amount of solutions to a problem. So the end of the notebook kind of goes through a few different solutions. This one's my favorite though. This solution is my favorite because it's efficient, because it doesn't check the next numbers if we found one already. That's why I like this algorithm. Okay, any questions about this? This is the end of the notebook. Okay. Okay, I think we have enough to do the lab. Let me open it up. Lab 17. Okay, let me take a look at this. Give me 1 second, folks. I'm gonna skim through this notebook real quick. Okay, number 1. This is a reduction algorithm. Okay. This is a reduction searching algorithm. another reduction searching. What is this one? This one is this is a mapping algorithm. Okay. This one is a reduction. 5 and 6. Okay. I'm gonna help folks go over these things and then save part 2 for Thursday. Part 2 is a little harder, but it's more suitable for Thursday because we're gonna be giving hints to the next programming project, which pretty much consists of going through data structures like dictionaries. Okay. I would actually suggest folks to try this out themselves first, because this algorithms notebook is one of the biggest takeaways from a programming class. In programming classes, you're typically asked to solve some problem, meaning that you kind of have to think about it for a bit, and try things out. If things didn't work, then you should modify the solution and see how to fix it. So I think most folks are watching the recording, so please pause the video and try to go through these yourself. If anything, I'm gonna do a quick modification to this notebook because it goes over things that we never talked about yet. For example, this list right here contains some numbers. There are some other numbers here. It's pretty much a different representation. We skipped over this lesson a long time ago. There is this lesson called binary and hex. I skipped over this notebook and recommended folks watch a YouTube video instead. But this is only if you're interested in the low level details on how the data looks like in the computer. So these are just numbers here. 0x12. This is a hexadecimal number. If you're curious what it is, you can print it here. So I'm just gonna print this number. This is a literal. It's a Python literal that represents a hexadecimal. And if you were to print it, the default is going to print as a decimal. So yeah, this number represents 18 in decimal notation. The decimal notation means 10 fingers. I don't want to jump into too much about this, but you could also look at the next number here. This is a binary number. Binary is a different way of counting, and it consists of ones and zeros. So this number here is 13. If you want to jump into this right here, you could, if you wanted to understand more on this, you could look at a previous video where I talked about binary and hex. But you could also get more straight to the point by looking up a binary hex calculator. And then this one might be fun. So we start off with the decimal 0. Decimal, as humans, we use a decimal system because we have 10 fingers, meaning that we have 10 digits, 0 all the way to 9. And when we run out of digits, we have to carry a number to the next digit. So 0, 1. I'm not sure if folks can read this because of the color, but in this, hold on, let me, yeah, this is kind of hard to read, but let me see if I can change my, I'll just leave it. Anyways, this says 1 for binary. If I were to increase again, in decimal, this is 2, but in binary, this is 1, 0, because binary only has 2 digits. So it ran out of digits and had to put a 1 on the next digit. And then I could go to 3. 3 in decimal is 3, and in binary it's 1, 1. And you can go on, right? You can keep going to 13. 13 is 1, 1, 0, 1 in binary. So that's kind of what's happening over here. 1, 1, 0, 1 is 13. If you wanted to look at a better animation, you could Google up something called like a mechanical binary counter. Once again, this is kind of off topic, but it's good to know if you're curious about the details. Here's a mechanical binary counter. It pretty much shows how things carry over. Computers have only zeros and ones on the inside, on or off. So 1, 2, 3, 4. This is what I mean by counting in binary. And then let me wait for 13. Okay, and there's 13. There it is. 1101. And yeah, hopefully people see what I mean. You don't have to worry about hexadecimal. This is another it's another counting system. Hexadecimal has 16 fingers instead of the binary, which has 2 fingers. If you wanted to change these numbers, you could. I'm just gonna go ahead and change this to a decimal notation. So 0x12, this is 18, and then binary number 1101, this is 13. So I'm just gonna change it to 13. I'm just gonna use all decimals here, and let me do that for the next list as well. Let's see, what's the numbers again? 18 and 13. So this is 18, 13, same here, 18, 13. Okay, I think that's it for the numbers. Okay, if you're on the recording, please pause the video and try these out yourself. Let's see. I'm gonna go over a few of them right now. This first one we already did. It's saying write a for loop that calculates the sum of all the elements. We were writing functions in the lesson. You see how in this lesson we wrote functions over and over again. This first part of the lab isn't really asking us to write functions yet, but you will have to write functions later. I think it's towards the end of this lab. Yeah, over in part 2 you'll be writing functions. But yeah, let's go ahead and sum it up. So we need to write a loop that goes through this sequence and reduces it to a single number. Just like previously, you could think of it as declaring a result that starts at 0, and then we're gonna accumulate it. It's gonna get bigger and bigger as we loop through the list. So as we loop through a list, we need to accumulate result, meaning it's gonna get bigger. People see what I mean here? We did this in the lesson earlier. So there's the result, and then let's see, we also need to print it. So let's go print result here. Printing, I'm putting it outside of the loop, so I only get one print statement. Okay, let me test it. So the sum is 326.4. Yeah, that looks about right. Yeah, that's probably right. All tests pass. Great. And if you wanted to debug it, sometimes you get errors in code, so it's sometimes necessary to print things. So if you wanted to print it, you could say result is currently, if you want to visualize what's going on, I'll put a print statement here, and then the final print statement, I'll just say result is finally. Okay, there we go. So I'm gonna press play here, and there we go. It's a little more easier to trace. This is the loop. The loop is accumulating the result, and then when we quit the loop, it's finally this number here. Okay, people cool with this so far? Some reduction algorithms. All right. Let's see. Number 2 and 3, these are pretty much the same questions. They're asking us to find the minimum and maximum. So I'm gonna just go through the maximum here, and then folks should be able to do the minimum by themselves. Sometimes it's necessary to search a list and determine what is the biggest value. In this case, the biggest value is 239, but we should probably design an algorithm so we can work with any list. This is a kind of like a searching algorithm where we're going through all of the values and searching for the biggest number. It's kind of like a reduction algorithm too, because we're going to pretty much collapse this whole list into in a single number. For example, imagine if we had like a function called minimum. Oh, you know what? So Python does have a function called min, which is literally gonna do all the work for us. So that's not really the point of this notebook, though. You know, here you could say, what is the max? Max. That's what I meant, not minimum. You could say, hey, what is the max of my list? This returns a value, so I'm gonna go ahead and print that value. This prints 239. So yeah, you know, we did it. But the whole point of this day is to unpack the inner workings of this algorithm. So we should unpack it. Like if we had a function, I mean, not a function, because this question isn't asking for a function, but if we were to design a function, you could call it like my max, meaning that this is like some value. This is some value. It's going to return a number. So you could say biggest number is equal to this. Print out the biggest number. I think we can. I think we should design a function actually, because we'll get much more out of it. This notebook doesn't ask for a function, meaning that this testing cell right here will probably fail. So I'm not gonna play this testing cell because we're writing functions even though this didn't ask for it. Okay. We need to define a function called myMax, which is supposed to collapse a list. So I'll name it values here for list. And you know, for now, I'm probably just going to return a dummy number. I'm just going to return like a dummy number, like -1. This is a temporary placeholder. So if I were to say biggest number is biggest number, put this in an F string. Currently biggest number is -1, but the biggest number should be 239. Okay, so how do we design this algorithm to find the biggest number? If you're on the recording, go ahead and pause it and think about it. Okay, there's an infinite amount of ways to calculate this. I like to bring up this analogy called the high watermark algorithm. So I'm going to be implementing something called the high watermark algorithm. Let me pull up a picture that will describe what I mean by this. Imagine you're at a beach and the waves come in. The waves will make a line in the sand. The line represents the biggest wave. So here's a picture of the boardwalk. A wave, this line, this water line in the sand, people see it, this darker area, this kind of represents the biggest wave that happened. If a bigger wave came in, the water line will change. So the water line is going to be bigger, closer to the coast. If a smaller wave comes in, like this smaller wave, the water line will remain the same. You know what I mean by water line? As waves come in, the line in the sand represents what the biggest wave is. So you can think of this as a variable that gets updated. You can think of a the variable that represents the biggest line in the sand. All right, people see what I'm saying by the high watermark algorithm. But basically, we want to keep track of the biggest number with this line over here. Sorry, we can't see my mouse, but let's go ahead and design this. So going to the notebook, I'm going to use like analogies here, so it's a little easier to understand. But basically, there's like a watermark. So I'm going to pretend like there's a watermark here is equal to something. What should we initialize our watermark to? Meaning, what should we start it off at? There's a lot of different ways you could start this off at. Most people will start the watermark at the very first wave. You know what I mean? Like the first wave comes in and it makes a line in the sand. So that's what I'm going to initialize it to. I'm going to say watermark is equal to the very first value. People see what I mean? Watermark, and then at the end I'm going to return it. I'll call it waterline instead of watermark. I'll call it waterline. So this is saying initialize a number that uses the first wave. So if we were to go ahead and play this, we see that biggest number is 1, which makes sense because the algorithm is hard-coded to say it's the first value. And in this case, the first value is 1. Okay, now we need to kind of simulate the waves coming in. So you can imagine this as a for loop, right? For every wave that comes in, we should probably update the water line under some condition. If the wave is bigger, then the water line will be adjusted. You know what I mean by that? The water line will be adjusted if the wave is bigger. So the condition here is if the number is greater than the water line. This is saying if the wave beats the previous max, then we're going to update the water line. People see what I'm putting here. For all of the waves, you know what, let me make this more analogous. So this number is a wave. These values is like a waves right here. I'm just gonna change some numbers. Okay, so I just kind of changed the vocab here a bit to be more analogous. But yeah, for all of the wave in waves, if the wave is bigger than the current water line, then we're gonna update it. And let's test it. So there we go. I just pressed play, and biggest number is 239. That makes sense. Okay, let's do some debugging statements in here because this is it might be useful to visualize what's going on. Inside of the for loop, I'm going to print out, let's see, actually in the if statement, this if statement represents that we beat the current water line. So I'm going to do a print statement here that says found a bigger wave. Okay, and let me see, found a bigger wave. Let me do some more print statements here. Print looking at wave here. Be careful for these singular and plurals. Here I'm using singular. Okay, looking at wave. And then if we found a bigger one, do a bigger wave. And then inside of this loop, I'm also going to print water line is currently. Okay. Hopefully people will see what I do. I just added some print statements here, which is going to allow us to trace the function. Okay, so let me press play. There it is. There it is. Let's go on what's happening. The algorithm sees 1, so it's looking at wave 1. The water line remains at 1 because it's not bigger. The algorithm then loops to the next number, 2. 2 is a bigger wave, so the water line gets updated to 2. Okay, and then we see 3.4. 3.4 is bigger, so we update it to 3.4 here. So that's the new water line. And then go to 239. This is also bigger, so we update it again. But then we get to 43. 43 is not bigger than the current water line, so this is not a bigger wave. The water line remains at 239. And then we go to 18. This is not bigger. 13 is not, and same with the rest. So the water line remains at 239 for the rest. Okay, people see what's going on here. Hopefully people are okay with this analogy. The water line. It's representing this picture here. So yeah, this is a really good classic algorithm. Yeah, a lot of things happening, right? A lot of things happening. So yeah, all we really did here was unpack a provided function called max. Python already has a function called max, and it can take a list. The list is really doing the same thing. So yeah, these two lines are the same. It's just that our first one is customized. It's allowing us to unpack what's going on in the original one. All right, people cool with this so far? I know it might seem kind of annoying because we're really just redesigning the wheel. And I know sometimes you don't have to redesign the wheel, but it's, in my opinion, it's good to at least study how the wheel works. This way you can possibly improve that wheel, or maybe you can possibly make it more efficient and run a little better. Okay, people cool with this so far, the high watermark algorithm? Okay, this does use a function. The question didn't ask for a function, so it's probably gonna fail if I run this feedback cell. Okay, yeah, it failed, but it's still the correct solution. It's the auto grading thing here didn't expect a function, so yeah, don't worry about this right here. It's correct. Any questions about this? Okay, cool. With this in mind, you should be able to do the next question. It's the same thing, but opposite. Find the smallest value. Okay, I'll let folks do this at home, so I'm just gonna skip over this. Let's see. Let's move on. Give me 1 minute. Okay, let me take a look at this. Okay, let's go over this one as well. Number 4, boldface. This is asking us to do a mapping algorithm. A mapping algorithm aims to convert a list into another list of same length. Oh, like right here. So this is what we're gonna do. We're gonna convert a list to another list. In particular, it's asking us to create a list where all of these strings are modified. And we're gonna modify it to surround it with bold tags, just for here. So you can imagine, with a mapping algorithm, we're going to create another list. Like imagine a algorithm called output. Imagine a list called output. Or actually, you know what? This question is asking to make a list named bolded. So I need to name this bolded. The goal of this function, well, it starts at a minimum. It starts with nothing here. The goal of this question is to map all of these values into here. So we should, we should end up with a list that looks like every string is surrounded with bold tags. in this case, I'm kind of just hard coding it. So don't type this. But please don't type this. I'm just trying to show people what we're trying to do. So yeah, this is our goal, to map all these strings, surround them with bold tags. This is hard coded, meaning it's not going to work if we change this list up here. So let's go ahead and generalize this a bit. We start off with an empty list, bolded. Our goal is to go through all these items and change them. Change them and insert it to this list. So the item here is a string, and we need to surround it with bold tags. So I can put 2 strings here that represent the bold tags. This is some HTML stuff. There it is. This line represents this string over here, the eat, with bold tags on the side. This is the modified item, so you might want to store this result somewhere. I'm going to store it into a variable called modified item. So modified item is a string that represents all of these put together. And we now need to append this to the list. So bolded.append modified item. The reason is because we're doing a mapping algorithm, so we're populating it. Cool, and then now we can just print it. Print out the bolded, just to verify what the list looks like. So press play, there we go. Our original list got mapped into this list. It's a list of HTML strings, or it's a list of strings. If you want to do some more debugging, maybe some print statements here. You don't have to do these print statements, but I'll do it just so people know how to problem solve things if things break. So I'll print current list is bolded. Press play, and we're gonna get a bunch of print statements, and we see that the mapping algorithm is building the list, making it bigger and bigger. Okay. Yeah, that's pretty much it for this one. Let's move on to the next one. This next one is pretty much the same as, actually no, it's not the same as previously. This one is a reduction algorithm. It's once again a reduction algorithm. Going to the lesson. Aims to convert a sequence into a single value. In this question, is asking us to convert this sequence to a single string that represents an unordered list in HTML. So going back to the HTML lesson, we're basically trying to convert a list into an unordered list, which looks like this over here. Back in the HTML lesson, an unordered list looks like this right here, where each element is a list item, and all of the list items are wrapped in the tag. This UL tag stands for unordered list. So yeah, we want to write an algorithm that goes through elements and puts the elements in this string. So yeah, once again, you should try this out. It's actually a really good practice if you try it out yourself. But here, I'll help you get started, and you can feel free to pause whenever. So the goal of this is to create some string. I'll call it like my HTML. And I'll initialize it to empty for now. You can think of this however you want, but there's going to be some algorithm down here that populates this string. It's going to populate the string where the HTML is gonna look like a bunch of list items. Here, please don't type this. Please don't type this. I'm hard coding right now. But basically, it's supposed to look something like eat over here, and then go to the next element, append the sleep. Go to the next element, append program, repeat. And yeah, so the algorithm is building a string that looks like this, and then maybe you can add in the unordered list in the end. So you could say there's a UL here, and then do a UL here. Right? The goal, this is our goal. So yeah, once again, please don't type this. I'm hard coding things so you see what it should look like. So yeah, let's start off with an empty string. We need to go through all the elements here. For item and items, you saw the first step was to kind of, modify the item and wrap it with the li tag. So we are gonna, on both sides of this each string, there's gonna be a li tag, which stands for list item. This is HTML. So for each item, we're gonna create a string. Right, this does return something, so I would probably store it into a variable called modified item. This represents a string, and we can just add this string to the original HTML. You see what I mean here? So my HTML, this is a string that accumulates the modified item. So it's going to get bigger and bigger. So my HTML is equal to my HTML plus modified item. People see what I mean here? This is accumulation, where we're accumulating strings. So let's test this real quick. We're not done yet, and it's a good idea to sanity check things along the way. So I'm gonna do a print statement inside of the loop that helps us visualize what the HTML is. HTML string is now HTML, my HTML. So I'll press play here. Okay, cool. We see that the HTML string is accumulating things correctly. With HTML, the new lines don't really matter, so it's okay for things to be on one line. Okay, cool. We're accumulating correctly. Now we just need to surround the whole list items with a big tag. Going back to the lesson, the HTML lesson, the unordered list is represented by these tags over here, UL. So yeah, we can say that in the end, our HTML string, the resulting HTML string, should be wrapped. In particular, both sides of it should have the tag. So I'll put a tag here for unordered list. In the end, another one, the closing tag. This is an expression that returns a string. So I'm gonna store this string into the original my HTML. People see what's happening. So we calculate the right side and then store it into the left. And yeah, let's verify real quick. Let me verify. Sanity check. Resulting. I'll reuse this print statement here. Reuse this print statement. So boom, HTML string is finally. And then let's test it. Okay, cool. It looks like looks good. HTML string. This looks good. What else do we need to do? Display the list. Okay. Cool. So to display the list, there's a couple things we have to convert this string into an HTML. This is stuff from a while ago, so feel free to look at the previous lessons. So we convert the string to an HTML object, and then go ahead and display it. display. This is like a fancy print function. And then, oh, we forgot to include this library. This HTML conversion comes from the library. I think it's called, let's see, I think it's called, let me just look at the previous notebook. Go to the very top. Here it is, from this here, from the interactive Python library. So boom, paste. Okay, there we go. Cool, so here's our debugging statements, and then the final one, display. Perfect. Perfect. Cool stuff, right? Pretty cool. So yeah, we just did a mapping, a reduction algorithm. The reduction algorithm takes a sequence and collapses it into a single string. Okay, any questions about this so far? Okay. Cool, cool. Let's do one more and then we'll cover the rest on another day. Let's see. So I'll do this one more function, and then I'm actually gonna go back to the previous lesson. So the previous lesson on algorithms, I'm gonna do some more advanced algorithms. So let's stick with me. Stick with me, because it's gonna help out with the future assignment. Okay, this next one is asking us to write a function that modifies a list. Okay, meaning that if the function did exist, and if we said add me for some reason, if we said add me and then put in some list, let's see. So let me just hard code like a test list here. I'll hard code a list of some strings. I'll just say like hello world. Basically we said add me to test list. The goal of this function is just to add another string here, meaning that if we were to print the test list here, if we were to print it, it should print hello world and then another string in the end. So let's go ahead and define this function. Okay, the function is called add me. The list, you can name it whatever. The question asks it to be called this. Cool, it's not going to return anything because the whole point of this function is just to modify something. For now, I'm gonna do a dummy return statement real quick. I'm just gonna say return none. You actually don't need to return none, but this is just to complete the function, so I don't get syntax errors. So I'll press play. If I press play here, it says hello world. It's printing out the list, but the goal of this function is just to, for some reason, add another string. So it should say hello world and then another element that says added. So yeah, this function needs to modify this argument, the list argument. We need to append this added string for some reason. And yeah, once again, you don't need this return. It's not needed. It's the same without it. There it is. So let's play it. So press play here and then press play here, and boom, people see what's happening. We initialize a list with 2 random strings. We called a function which modified the list. And yeah, this question is really just showing you that functions can modify lists. It's actually bringing up a concept called a mutability. In Python, lists are mutable. You don't really have to know this too much, but if you were to go on to the next class, certain types are not mutable. Mutable means, are you able to change it? Lists are able to change, so that's the whole point of this. Okay, any questions about this so far? Okay, cool. And oh, here's another invocation that reuses that function. So if we were to reuse the function with this other list, it should do the same thing. Yeah, same thing. Got the added here. Okay. Any questions about this so far? Okay, cool. We did most of the lab. There is a part 2 here. This is a little tricky. I think folks should try this out. They're a little challenging. They're a little challenging. Likely to be on the exam, some sort of variations. Yeah, go ahead and try it. If you're not sure what's going on, let me unpack what the expected value should be. Let's see. Let's just say we had some sort of dictionary here. Like, let me just hard code in some more values actually. Oh, I can't even modify this cell. Let me change this cell here. Make it editable. Basically, this dictionary is arbitrary. It could be anything. If there were another thing, if there were another value here, like let me just say test key, test value, and let me just do another one. Now the dictionary is arbitrary, so if I were to say something key, something value, our goal here is, if we had a function called reverse get, this is like the opposite of accessing things in a dictionary. Like here, let me comment this out real quick. You know how with dictionaries we can index things? Like if we said we can index things based off the key. Like if we said D and then put in like a test key, dictionaries will say, hey, this is the key, so it's going to return us the value here. And let me print it. Yeah, you see what I mean? It's giving us the value here. And yeah, if you go foo key, this gives us the foo value, because that's how we access dictionaries. Basically, the point of this function that we're supposed to write is to do the opposite of this accessor. In Python, dictionaries can they're kind of like one way, meaning that we can't really access keys by its value. If I were to say access foo value, well, you know, one might expect this to return foo key, but dictionaries are kind of one way. This gives us a key error, because by default, dictionaries in Python will grab the key and then get the value. So, you know, this right here, there is no such key named foo value. So yeah, this error doesn't make sense. This is a limitation of dictionaries. The limitation is we can't really index by its value. So that's the point of this function. The point of this function is to design something that does the reverse. In this case, this function is saying, hey, what is the key that's associated with this value? So if I were to do like, here, let me print this actually. Let me print this. So if you were to print it, it should print foo key. If you were to try this again with a different one, if I were to say like something value, this should print something value. I mean something key. You know what? Let me make this a little more concrete because this is a little general. Let's make this more concrete. Let's pretend this dictionary contains student IDs instead. So let me copy this cell over. Let me do the same thing but with a more concrete example. A more concrete example. Say this dictionary contained like I'll rename it to like student, or I mean it like student IDs. You know what, I'll call it, let me think. Yeah, I'll just call it student IDs. Basically, I'm just gonna use all strings here. So if I were to have like a string that says 0, 1, 2, 3, 4, 5, this goes to Alice for some reason. And then if I go like some more numbers here, 2, 3, 4, Bob, and then another one, put Charlie here, and maybe Charlie has a 5, 4, 3, 2, 1. You can imagine that this dictionary is, you know, storing IDs, goes to Alice here. So if we were to call this function student IDs and search by value, if we were to go something like this, searching for Alice's key, this should print 0, 1, 2, 3, 4, 5. And then if we did it with Charlie, this should print this number here. People see what I'm saying because once again, we're limited with the implementation of dictionaries. We can index things by the key 33333. This gives us oh, I missed the 3. This gives us Bob, but we can't do Bob and have it give us the number because that key doesn't exist. So the point of this is to design some sort of searching algorithm. Basically, this function should kind of search through all of the keys and see which key matches the target. So let me help people get started on this function. The function here is called reverse get. It takes 2 values, the dictionary and then something called a value. You can actually name this whatever you want. In my opinion, a better name is target because we're searching for a target and returning a key. So yeah, you could rename this to target if you want. And yeah, the doc string here, right? It's what we said earlier. The purpose is to search for the key that matches the target value. Okay. Let me see. There's some parameters here. There's a dictionary and then the value. Target. The value to search for. And then it's going to return the key. Yeah, so yeah, I would recommend trying this out. I'm going to return a dummy statement for now. Return just for a temporary placeholder. It's going to return not implemented yet. Okay, and then run this, not implemented. Cool. Yeah, go ahead and give this a shot. It's a pretty good one actually. It's a really good algorithm. What else? Frequency counter. This is also a more difficult one. Write a function, take a single string argument, counts how many times. Yeah. Here, let's talk about what the expected result here is. This question is asking if you can implement a function that counts letters. That's really what it's saying. In particular, if I were to have like a string here, like this is a pretty long text here, but if I were to deal with like a smaller text, like let me think. Let me just make another cell here. Like let's say there's a small text that's a little easier to read. I'll put in a single line string like hello world. Wait. Yeah, I'll just reuse this example here. Hello world. Basically, it's saying that if we were to test the code down here with another cell, count letters, small text, this line should evaluate to a dictionary that represents. I'm just gonna copy this up here. But basically, the function should create a dictionary and keep track of things, where each key represents the letter that it encountered, and then the value represents the what's it called, the frequency. So this should evaluate to a dictionary that looks like let me make this a multi-line. There it is. Yeah, suppose it look like this right here. It's probably gonna print out ugly. I'm not sure. It's probably gonna print out looking like this right here. Okay. Any questions about this so far? This is a good one. This is actually a really good, what's it called? Practice, because you can think about how word clouds work. Like you could, have you ever seen this thing before, word cloud? Basically, some programs will look through large text and it will display the most frequent words, where the most frequent words are the bigger ones. So that's really what we're doing, just in the just with letters instead. This is useful stuff because it's kind of like the basics of how search engines work. When you Google things up on Google or Amazon, it will suggest things, and part of the suggestions are based off a algorithm that counts frequencies. It's not really the whole algorithm, but you know what I mean, right? When you search things up on Google, the frequent searches will appear, and the reason that works is because there's a Google function that kind of keeps track of frequencies of certain things. So yeah, this is a good one. Okay, yeah, go ahead and try it out. Okay, let me see. We're at. Okay, cool. We got 15 minutes left. Let me see. So we just went over the lab, and folks have like a few more questions to do. I highly recommend spending a lot of time on this. And if you need some more practice, I would recommend Googling something like Python function practice. This is for people who are maybe future software engineering or future computer scientists, where you might need some more practice. And this is a good exam practice, by the way. A good exam practice is, write a function that finds a maximum of 3 numbers. So we did this already. We did this with a list instead. Oh yeah, we also did this as well. Write a function that sums up all numbers. Perfect, we did that. Try this one out. This is a good one. These are all highly likely to be on the exam. It's going to be some sort of variation of these. Yeah, these are very good practices. Okay, yeah, it's some good stuff. I'm just trying to say that the looping algorithms is a really big takeaway from a programming class, or algorithms in general. Okay, let me quit this lab. Hopefully people can try it out by themselves. Okay, give me a minute. I'm gonna look at the lesson real quick. So here's the lesson. I'm thinking about taking this lesson a step further. Let me think. Should I take it a step further? Maybe we could. Yeah, let's take this one more step further, which will help us out with the next programming assignment. The next programming assignment is called Major League Baseball Players. I'm gonna go over a sneak peek of this in 2 days. So let's take this lesson a step further, which will kind of help us out with the programming project. Okay. Back in the lesson, we did a filtering algorithm. We used a scenario that filters grades. Let's see, let me look at a different one. Okay, yeah, perfect. We use an algorithm that filters grades. And typically data isn't really represented with just pure numbers. In Canvas, the numbers are associated with students. So a more accurate representation of this is more of a nested data structure. Imagine that the data looks like this right here. Instead of a list of integers, maybe a list of dictionaries. So you'll see what I mean in just a bit. So here, let me rewrite this. I'm gonna define grades as a list of dictionaries instead. You'll see what I mean, because each number needs to be associated with whoever got that grade. So maybe you can imagine there's like a list of dictionaries. This is, you don't have to represent it like this, but you'll get a lot out of it. Okay, 1, 2, 3, 4, 5, perfect. Each dictionary kind of represents the file of a student. For example, this student is named Alice. So I'll say name Alice. And let me make some more here. Let me say Victoria there. And let me put Bob here. Let me put Jim here, and then another one. Let's see, name, I'll go David. This is a dictionary. So far, they only contain one key value pair. Typically, data has more stuff. So each dictionary would have more key value pairs. Like maybe you can imagine another pair that represents the grade. So you can imagine that there's like a grade, and maybe Alice got 90. I'll represent this as an integer actually, because we're planning on doing math with it, or not math, but it'll make things a little easier. So grade here, this is 100, and then let's say Bob has a grade of 0. Let's say Jim is 70, and here grade is 47. Okay, cool. This is typically what data will look like where there's associations on grades. This might look a little hard to read because things are on one line, but each dictionary kind of represents two elements here. So if you wanted to make it a little easier to read, you could put things on multiple lines. Like, let me see, how can I make this a little neater? Let's see. Hold up, I think I messed my spacing up here. Okay, I think this is a good format. Yeah, this is a good format, I think. Is it? Yeah, the formatting doesn't matter too much. I'm just doing it for readability. Okay, I know this might look really hard to read, but this is really useful stuff. The next programming project will have a similar structure. Okay, and finally here, I did hard code some things. So yeah, this is a list of dictionaries. It's a little more practical. Each dictionary here has 2 key value pairs, so you can kind of access things inside of it. I think I messed up my spacing. Let me fix the spacing up. Okay, you know what, let me make sure my syntax is good actually, because there's commas, there's parentheses everywhere. Let me make sure it runs actually. So press play. Okay, cool. I just commented out these because I wanted to see if I initialize it correctly. And let me do one more print statement just to see. Okay, so I just did a print statement, print grades, and yeah, there it is. It looks like we represented a list of dictionaries. Okay, so say we were to iterate this. Say we were to write a filtering algorithm that goes through the data structure and tells us who passed. So we should end up with a similar data structure that contains only the passing students. This is a filtering algorithm. So if we were to have a function called filter passes, first of all, this probably might not work. Before I press play, we should probably trace it, see what's going on. This is not going to work because grades right here. This is a dictionary, but the function is expecting a list, because when we go into the function, we see that values here will be dictionary. So when we iterate through the dictionary, we're technically going through all of the keys. Here's what I mean. So in the previous lesson on the for loop, we talked about going through dictionaries. By default, when we iterate a dictionary with a for loop, it'll go through the keys. So if we were to use this function, values will be dictionary, and we're going to be looking at all the keys, which isn't really a thing. No, my bad. Values is a list. I take back a lot earlier. This is a list of dictionaries. So when we go through a for loop, we're technically iterating a dictionary. So you can imagine that a representation of this is dictionary. Oh, I made it read only. Let me change this. So you can imagine that this number is no longer a number. It's actually a profile. You know what I mean? Because it's going to iterate through this first element in the list, which is technically a profile. And it's going to go to the next one, next profile, next one. So yeah, people see what I mean. We're going through the profile, and we can't really compare that whole profile to a single number. You know what I mean? We we can't just say for profile in values, if the profile is greater than 70, then append the profile. You know, in English this kind of makes sense, but it's not going to work because profile is a dictionary, so both these sides don't match. You can't compare a dictionary with a number. And just to prove it, let me press play here and then invoke the function. We're going to get oh, hey, we got a debugging message. So it looks like we were able to iterate once. It went through the function and printed this, but then failed down here. You see what I mean? See, we were able to print that once, and we got a failure here. It says can't compare dictionary with integer. So yeah, that's what I was saying earlier. Because this is a dictionary, you know, you can't really compare dictionary with a number. So we need to go into the dictionary and check if the grade is greater than 70. So we need to access the value associated with the grade. You see what I'm doing here? So if the profile's grade is greater than 70, then we're going to append the profile. And finally, if we press play here, you see what's happening? The filtered list is empty. The algorithm sees Alice. Alice has a grade greater than 70, so she gets added. And then we go on to the algorithm goes to Victoria. The grade is 100, so that person gets appended. And then the algorithm sees Bob. Bob is not a passing student, so the algorithm remains the same. The filtered list remains the same. You know what I mean? These two lines are the same. And then we go to Jim. Jim is a passing student, so we end up with Jim here. And then finally David. David doesn't do anything, so it remains the same. Okay, and yeah, you can go and print out the result. This is going to let me make it a little neater here. I'm just gonna print out like a bunch of equal signs here. Just to make things a little neater. There it goes. There is our final output. Okay, so let's summarize what we did. We took this a step further. Earlier, this function was designed to take a list. But with our scenario, a list of grades isn't typically just a bunch of numbers. It's typically nested data structures, meaning in this case, we have a list of dictionaries. So we redesigned the function to iterate through all of the dictionaries and go into the dictionary, right? Go into each dictionary, grab the grade, and filter it. So yeah, this is more in practice. And I did hard code these numbers. In practice, you typically do something like grades equals canvas dot download data. This is typically what it would look like. You'd have to import something. You have to import like canvas or something. You know what I mean? Okay, but yeah, I just hard coded it for now. Okay, this should be good for sneak peeking into the next project. The next project is called Major League Baseball Players. We'll go over this in a couple days. Okay, thank you all for coming, and go ahead and give that a shot. The lab on 17. So see if you can complete the rest of this. Okay, have a great day, folks. Bye-bye.